In this video, I'll go over Exam 4, Question 2. Question 2 states, a 100-gram ball of clay traveling at speed 10 meters per second hits and sticks to a 1.0 kilogram brick sitting at rest on a frictionless surface. Part A of the question asks, what is the speed of the brick after the collision? Part B, what percentage of the mechanical energy is lost in this collision? And Part C, is this collision perfectly inelastic or elastic? Well, the answer to that is perfectly inelastic because the two masses stick together. And as we see, have a loss of mechanical energy in the collision. So let's do part A now. We should have a figure here showing initially mass 1 has a momentum m1 times v, and that's the only momentum of the system. And then later, mass 1 and mass 2 are stuck together, so there's a total mass of m1 times m2 and a velocity of the combined system of capital V. So this is an isolated system. There's no external forces acting on the system, so linear momentum is conserved, even though it's perfectly inelastic. So we have the momentum before is equal to the momentum after, or m1v, which is the momentum initial, is equal to m1 plus m2 times uppercase v for the momentum after the collision. And then solving for uppercase v, it's equal to m1 over m1 plus m2 times the initial velocity. And putting in the numbers, we get 0.91 meters per second. Then going to part B, we want to find what the percentage of the mechanical energy is lost in this collision, which is kinetic energy lost. The initial kinetic energy is 1/2 mv squared. And we can go ahead and calculate that. It's equal to 1/2 times the mass, 0.1 kilograms, times the initial velocity, 10 meters per second, squared. And that's equal to 5.0 joules. The kinetic energy finally, or after the collision, is equal to 1/2 times the new mass, which is m1 plus m2, times the v final squared. So putting in the numbers, that's 1/2 times 1.1 times 0.91 meters per second, all squared, which is equal to 0.455 joules. So the fraction of energy lost is equal to K initial minus K final over K initial, which is 5 minus 0.455 divided by the initial kinetic energy, 5. And that's equal to 0.91, or 91%. And as I already stated, this is a perfectly inelastic collision. And that concludes this video.